Okay, so this video is on point reflections. What we did in the line reflection lesson was kind of make sure that you understood the main concept for line reflection was the line we reflect over or through is the perpendicular bisector. For any pre-image to image segment. So that was the underlying concept in line reflections. The underlying concept in a point reflection is just a little different. The point we reflect through or over is the midpoint. For any pre-image to image segment. You know, so if you're looking at something like this, where you have point A and you're reflecting through point P, basically what you're going to do to find A prime is you're going to draw a path straight through. So straight path. So point A, is going to travel along this path straight through P. Well, how far do you go? Well, whatever this is. Say this is 10, right? So you're going to go 10 on this side, and A prime would be about there. What that's going to do is that's going to make P the midpoint of A to A prime. Okay? That makes it a point reflection. Okay, so that's what we're looking for right there. So slightly different. Okay? Of course, you know, that's without a graph. That's one of the areas that we'll study. Now, if it is on a graph, it's a little different here. So typically we're going to reflect through the origin, but I'll show you that it can be reflected through any points. So let's reflect through the origin, point B. Let's give you the coordinates of that. So -3, 5. Okay? And we're going to reflect through the origin. So 1, 2, 3. So there's B. There's the origin, 0, 0. And basically what we're going to do is we're going to try to find B prime. So act like this is basically the midpoint, okay, of B to B prime. So what would you do? Well, I usually go like this. We've got to go right 3, down 5, you know, to get to here. If we use that same right 3, down 5, that right there is going to have to be B prime. Okay? So that's the path B travels along, and it's going to end up stopping right there. Okay? So you can continue using the same slope if you want, and then make sure it's the same distance away. So B to the origin, usually we call it O, is the same as O to B prime. So that's going to map to 3, -5. Okay? Let's try another one. Okay, so now what we'll do is reflect. Now, little r is reflect. And when they give us coordinates, let's go with, like, let's say 1, 4, right? So we'll reflect through the point 1, 4, point C to get C prime. Okay, and so let's make C, I don't know, we'll say it's 0, 7, right? Okay, so where does it map to? Well, let's first start with 0, 7. Okay, that's C, and 1, 4 is, we'll call it P for the point we're going to reflect through. Now, here's how we do this. Remember, the path that C is going to travel is straight through P. So it's a slope of over 1 down 3. You could do that again. Keep doing that. Okay? So this is the path that C has to travel through, okay, to get to C prime. So basically it's C prime's path. All right? Now how far away? Well, if this is over 1 down 3, to make P the midpoint, do over 1 down 3 again, and that's going to be C prime. Okay? So if you connect those, is P the midpoint of C to C prime? The answer is yes. Now the coordinates are at 2, 1. Oops, sorry, C prime. And, so some of you are trying to guess as to what's going to happen. If you guess as to, say, what's going to happen to points, when we reflected through the origin, it did in fact look like it was going to be just negate the coordinates. Okay? So that's pretty good, if you notice that. However, it didn't work here. It's because there's a different point that we're reflecting through. I don't need you to memorize this, but this is basically what happens. Okay? And it's based on the midpoint formula. So here's what's going to happen. You're going to double this and subtract from x, okay, for the x value. And then you're going to double this and subtract y. That's always going to be what happens in a point reflection. Okay? Now here's the reason. The whole underlying reason behind this is that the midpoint formula, which we didn't do a lot with, but we need to, is add the x's, divide by 2. Think average, right? Add the y's, divide by 2. Oops. So think average of the coordinates. Right? Well, let's take a look. Okay? If we look at that right there, what's going to happen if we apply the midpoint formula to this? Okay? You're going to get x plus 2 minus x over 2. Think x plus 2 minus x. We're going to add them and then divide by 2, right? And then we're going to take y, oops, and 8 minus y. Y plus 8 minus y over 2. X plus 2 minus x is 2. All right, the x's knock out. Here the y's knock out, and we get 1, 4. So that's the point we reflect through. So that's basically how you're going to do that for point reflection. All right. So there's lots of problems to work through here. I'll go grab a couple from the homework and help you with those, and see if you can, do the rest on your own. Okay, so page 11 in your homework packet. I'm just picking some random ones. Okay, so we're going to find the image of 3, negative 4. Sorry, negative 3, negative 4 after reflection through this point. Okay, so here's negative 3, negative 4, and here's the point 1, 2. Let's just call that A and P, right? Okay, so remember, if you're reflecting through a point, P is going to be the midpoint. Of A to A prime. So you think of it this way. I'm going to have to travel 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5, 6 up to get from A to P. Now if I keep that going, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, right? You're going to get that straight path. Okay? So you get these points to be along the same line, and the distance from A to P has to be the same as A prime to P. A prime to P. That's all we want. So that's 5, 1, 2, 3, 4, 8. Okay, so the point A prime is going to be 5, 8. All right, next one. All right, here's back to this rule. Okay, not easy. All right, this one's really actually going to be pretty challenging. So this has to do with a midpoint formula, or we could check out what happens. All right, let's actually take and check out. I'll grab a graph and we'll see what happens. Show you how to work this rule to get the answer. Okay, so to work the rule, here's what I'm going to do. I'm going to pick a random point. Okay, when I pick these random points, when I make these up for A, what I usually do is I pick 2 points that are different numbers. So something like this, okay? I'll pick 2, 6, all right? And based on the rule, if I pick 2, 6, right? Basically, I'm going to plug 2 in for x. That's going to turn into 6, right? So see that? 2 in for x, 8 minus 2 is 6. Throw 6 in for y, 2 minus 6 is negative 4. So I'm going to plot those 2 points and see what happens. 1, 2, 1, 2, 3, 4, 5, 6. That's A. And A prime ends up at 1, 2, 3, 4, 5, 6. 2, 3, 4. There's A prime. Now basically, how do you do this? When you reflect through a point, if I have the pre-image and its image, all I need to do is find the center, or the midpoint, I'm sorry, find the midpoint of those. So that's basically all I'm doing is find the midpoint. All right, so I'll do that. One way, 1, 2, 3, 4. So we went over 4, 1, 2, 3, 4. Looks like 10. So if I do half of that, they meet right there. That's where the midpoint is. So it's 1, 2, 3, 4, 1. So that point P is at 4, 1. Okay, so there's your answer. Oh, so let's do number 8. Let's do it algebraically first, just so you could see how to do that both ways. Let's try to work on finding the point we reflect through. Find it algebraically. Now, if we remember the concept that the point we reflect through is the midpoint of the pre-image to image segment. If we remember that, we can use the formula for midpoint. Okay, so midpoint, the formula is add the x's, divide by 2, add the y's, then divide by 2. So that gives us an average. All right, so let's do that. It's going to be tricky with the algebra, but we can do it. All right, so midpoint. All right, let's go grab, this is the x value that's going to replace x1 in the formula. So negative 6 minus x. Now x2 is going to be x, and then divide by 2. y1 is going to be this 10 minus y. Then we're going to add y, divide by 2. Okay, so here goes. So the midpoint for this rule, negative 6 minus x plus x, that's going to go to 0. So it's really negative 6 over 2. That's going to go to 0, so it's 10 over 2. And what we get is negative 3, 5. So that's going to be our answer. Now, that was pretty tricky, but you can handle it. Negative 3, 5. Let's verify it with a graph. What we do when we do this is we make up a point for A. Okay? We will map it to A prime following the rule, and we'll see if, in fact, the midpoint of that segment is negative 3, 5. So let's make that up. Okay? I'm just going to try negative 2, 10. Just something crazy. See if we can actually get this done. So negative 2, 10, if we follow the rule, right, we're going to take negative 6, take away x. Okay? So it's going to be negative 6, take away negative 2. So negative 6, take away negative 2. It's going to act like negative 4. It's going to basically add 2. All right, 10, take away y. It's going to be 10, take away 10. That was just luck. It was negative 4, 0. So let's go plot those 2 points. Okay, so I made up a negative 2, 10. I applied the rule. We landed at negative 4, 0 for A prime. If we want the midpoint, it's going to be right in the center of that segment. Let's see. Could do it this way. Over 2, 1, 2, oh, that's going to be 10. Do half of that. Over 1, up 5, we land right there. That's going to be the center or sorry, the point we reflect through, let's check that out. Negative 1, 2, 3, 1, 2, 3, 4, 5. Okay, that did end up being negative 3, 5. So we could verify it with an example, or we found it algebraically. So that is going to be the lesson on point reflection. If you watch through this whole thing, you should be able to manage any questions we might be able to give you on that. All right, thanks so much.